ray diagrams for converging lenses when the object is between f and 2f, right? So from the axis of symmetry to f is one focal length. And then when you double that, you get twice the focal length. So we're going to draw a ray diagram when the object is between between f and 2f. Okay, so the first ray we're going to draw, as usual, starts from the top of the object and enters the lens parallel to the principal axis. After that, it travels from the lens through the focal point on the other side of the lens. Right? It's important to note that on a converging lens, there's two focal points, one on each side. If we're thinking back to our converging or our concave mirrors, if we're looking at this lens here, we had a focal point inside here, and this would be the center of curvature, and same here if the lens would go around. And this would be the focal point, this would be the center of curvature. But we're talking about lenses now. So the light travels through the lens. But as it travels through the lens, it changes direction. As you'll notice, the first ray travels from the top here, right to the axis of symmetry, and then changes direction. The next ray that we're going to draw, just like in our last example, travels from the top of the object through the center of the mirror, where the principal axis and the axis of symmetry cross. Just goes straight through there. Okay, so then our third and final ray for this example, as usual, leaves the top of the object through the focal point this time on its own side of the axis of symmetry, hits, see, I'm going to try, redraw that one. And then this way, once it reaches the axis of symmetry, the light changes direction again to travel parallel to the principal axis. And you'll notice that our rays converge right here on the other side of the mirror. So this is our object. This is our image. So for the image, the location of the image is going to be farther from the lens. The distance from here to here is farther than from here to here. The orientation, all right, the object is pointing upwards, the image is pointing downwards, so the orientation is inverted. The size of the image is larger than the object. And the type of image that's produced is a real image, because all the rays that leave the object intersect again to meet up where we have a real image. That's a ray diagram for a converging lens when the object is between f and 2f.